All right, we are off and running a PF1 video 9. You guys making progress on your lab 2? I see some nods up and down and others averting my gaze, I guess, you know. So with a little luck, you've made some progress, maybe even got her done. I did get a couple of questions through email. And every once in a while, just looking to see what students are doing or what you guys are doing. I saw that, you know, y'all were working on it yesterday evening then also. I actually have an app that I wrote on my phone that allows me to execute commands on the server without logging in, which seems kind of strange, you know. They do have, of course, little terminal emulators that you can put on you know, certainly Linux or even on Android or iOS and so on. But I didn't want a terminal emulator because, you know, using a little virtual keyboard to try to log in with your username and your password, very awkward, you know. And so instead, I wrote an app that listens on a network port. Or actually, there's a server that's written in C that runs on our service, that runs on our server. That's written in C. And it's listening for these connections. Then the app just pops up a screen, and I can type in commands, and they just get sent to the server and executed. Then the server sends the results back without me having to log in, because there's some handshaking and so on that takes place in terms of security and so on. But anyway, it requires, it eliminates the need for me to have to type in a username and password. And so even though I didn't have power, our network router was down and so on, you know, all our computers we'd powered off proactively, you know. But I still could, just using 5G in my phone, execute commands to the server and see what was going on. And I did every once in a while just to make sure that we had power up here on campus and so on. That was kind of an easy way to do it. Anyway, I saw that a number of students were plodding along in their labs, so very, very good. Today's going to be a fairly easy day. We've had a number of those recently, in fact, which is good. So we'll wrap up a little early and then have some time, finally, for questions on labs if you have them. You know, the truth is this class is supposed to be a mixture of lecture and lab. But you guys know the drill, especially now. It's been a couple of years now that we've changed. We used to have math. How many of y'all took math 1414? The STEM version of college algebra. Did y'all? Yeah. Oh my goodness. So I've taught that class and a lot more of the 1314, the 3-hour version of college algebra versus the 4-hour version of college algebra. And anyway, the 4-hour version, you're supposed to have time for, you know, quote, lab time. Hey, all right, we're just on 2 legs, no crutches now. I'm glad to see that. You graduated past the crutches. But anyway, if you took math 1414, did you have a lot of time for questions and answers and all the rest on homework? Or was it just go, 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 go every minute of the day? And man, that's the way it was. There's just lots of material, very fast-paced course and so on. And anyway, PF1 kind of ends up being the same way. That we're just covering new material from beginning to end, you know. I wish it wasn't that way, but there's just a million little details, you know. But every once in a while, today included, it worked out well. We'll have a shorter lecture, and we have a lab that's assigned then too, so that'll be a good then. So if you need any questions answered, then stick around after class, and we'll do just that. So let's see here. Let me pull up my account. And we're going to talk about operators today, so a number of things we can do here, I guess. I'll go ahead and open this. All right, zap down to the bottom, kind of get it started. All right, video 9. Okay, and we'll minimize that. And so, again, operators, what we're going to talk about, and kind of related to that, I wanted to do a follow-up. You remember when we were talking about assignment statements and variable declarations and all the rest of that? We realized that, hey, if you have an assignment statement to a variable, and on the right-hand side of the assignment statement, you just have a constant or an expression involving only constants, no variables, in other words, then the compiler would actually look at the constant or the expression full of just constants and determine whether or not that expression or that constant will fit into the specified variable that you have on the left-hand side of the assignment statement. And so we wrote up a couple of those to kind of prove that sure enough, it seems like that the compiler will actually evaluate expressions. It'd be tempting to think that that would be left off until runtime, but as long as there's no variables involved, it'll actually do it at compile time. And so I've written up another one of these just for the heck of it. We'll show you here today. And it's actually a bit of a PF3 assignment, which hang around for PF3 and we'll get there, but it's part of a much, much, much larger expression that we use in PF3 as part of an interesting little lab here. And I just cut and pasted part of that up here. And, oh, you know, I ought to open that with Paint now that I think about it so we can write on it. And then just remember not to save it. But all right, so we'll do this. Come on now. Right-clicking, there we go. Open with. And paint. Oh, actually, Paint 3D would have been good, but this should be fine. Let's see. Can I zoom in on this? Where's my little? I thought I had a little zoom window. Okay, abort. I don't remember. We'll just. I think actually a shift page up or something. Control shift page up. We'll just do it Paint 3D. This is funny. This should be working. Okay, try this again. My system seems very slow today for some reason. All right. There's that. Hey, there we can zoom in on it. So here's an expression. And so just for the heck of it, we're going to just look at the expression and figure out what it's going to evaluate to. It's full of nothing but constants, so there's no variables in it. And so it's a bit much for you guys to have to scribble down and kind of do on your own. So we'll just do it as a group here then, I guess. But y'all keep me honest and kind of help me on this then. All right. So let's start with this first set of parentheses. So we've got a sum and a quotient, and then we're another sum involved here. I'll pull up a red pen, get my little drawing tool here. Okay, so you guys help me out and make sure and check my work on this and save me some embarrassment. We're all on the hook if I find it making a mistake here. All right, so this first little quotient, all right, 5 plus 1 is 6 divided by 2, and this is going to be a 3 here then. Oh, that's nice and fat, so we like that. Plus 1, all right, so all of this thing here in parentheses is a 4, correct? Let's do the same thing down over here. I'll let you guys just kind of look at it first, see what you come up with. I'll take a breather for a second, and I'll catch up with you then. Okay. 5 minus 3 is 2, so 8 divided by 2, this is a 4, so this plus 6, so this parentheses here is going to be 10, and we're multiplying that together, so all right, that's this set of parentheses here, that's going to be a 40. We agree on that? Are we in good shape? Okay, so y'all are agreeing with me so far. All right, let's kind of do the same thing down here. We'll tackle this first little quotient first. I'll give you just a second head start, and I'll catch up so that you can check my work. Okay, so 1 plus 2 is 3, plus 3 is 6. 6 divided by 3 is 2. All right, 7 plus 8 is 15, plus 9 is 24 divided by 8. 24 divided by 8 is 3. So this set of parentheses here, this sum is 5. Okay. And so I think we've got this all kind of done, except for just dividing the 40 by the 5. Am I right there? All right. So all of, that's kind of sloppy there, but anyway, all of this is going to be 8. Okay. So now let's worry about, this product here, a product which involves some other products and the difference in the sum and so on. So let's worry about, we do this whole thing here at once, I guess, just this part. Okay, 2 times 2, that's 4 minus 1. All right, so this 4 minus 1, that's 3. And this is 4 plus 1. Good grief, that's 5. And this product is 15. All right. And, okay, then we want to, of course, the order of operations kicks in here then. All right, order of operations. We've got multiplication before addition. So what's the product of 8 times 15? I think I know. Somebody blurt it out. Oh, 120 I think is correct. Ding, ding, ding. Very good. All right. And then plus 7. All right. Tacked in way over here. So we'll kind of bring that down to here. All right. Is equal to, I think, 127. So anyway, not too big of a deal. I think we're on the right track there. So an interesting little, medium complexity expression but involves just constants. And then what I've done is, all right, so let's go here and CD to PF1. So I got, every once in a while, I'll copy some of my notes from class into this directory here just to keep them for future reference or whatever. I can look at them. And so vid9 is going to be the first little file we'll look at. And again, it's a bit much for you guys to type in. If you want, anybody wants to raise your hand and I can copy it down to user temp PF1 for you. But anyway, vid9.java. Okay, and so we'll look at the code. Of course, good grief, all the scribbling I did on this thing here just about made it unreadable. So what I might do is come over here and multi-level undo to the rescue. There we go. All right, and to zoom out a little bit so we can move them over and we have a little bit of a chance to see. Yeah, there you go, kind of both things at once. And yeah, there you go. I think this will work just fine. So anyway, 5 plus 1 divided by 2 plus 1. We got this in parentheses here. That's this part over here. We're multiplying that by 8 divided by 5 minus 3 plus 6. Another set of, outer parentheses there. And then we're dividing that by, anyway, here's our denominator then, which is this sum, which we show here. And there's an extra set of parentheses around that whole thing. Now, once again, yeah, when in doubt, remember that little tool we showed you? I think it was just the last lesson. If you put your cursor on a parentheses or a curly brace or whatever and type a percent, it will take you to the mate of that. And so this one here, okay, so sure enough, there's our entire numerator. And down here, that's our entire denominator. And so anyway, so we have division and then multiplication. So, you know, which one takes place? Actually, we recognize it doesn't matter in this case, but since multiplication and division are at the same level of operator precedence, then we're going to evaluate that expression from left to right. We'll re-mention that again later today. But yeah, so we're going to do the division to get this quotient here, and then we'll multiply it by this over here, and then finally add our 7. And anyway, so I've just coded up that hairy expression there. It looks worse written out over here, I guess, than it does here, just a couple of lines worth. And we're assigning that to a byte. Variable b has been declared to be a byte. And if you remember, you know, a byte, 2 to the 8th, 256 possible values. So you have 128 that are negative and 128 that are non-negative, including 0 then. We tap out at 127 is the biggest value that can be assigned to a byte. And as it turns out, coincidentally or not, this expression evaluates to 127. So let's see here. So we will, all right, cat vid9.java, javac vid9.java. And it does compile. It does compile. But the interesting thing is then, we'll do it this way, vi vid9.java. We come down here and change that to an 8. And then we cat and compile, or try to compile. So isn't that something? Sure enough, it says, nope, ain't going to fit. You know, the 127, it gave us the thumbs up. But when this big expression here evaluates 128, the compiler actually caught that. I was kind of surprised first time I saw that, you know. But anyway, so it is what it is. Kind of interesting, I guess. So the compiler will evaluate expressions provided that they involve only constants. All right, so there's that. And I guess we're done there then. And so let's start talking about operators. So we're going to start another little program here then. All right. So let's VI manually here, vid9b then. And do I have some house cleaning? Looks like we were busy. It looks like last lesson. Remove vid everything and remove D, and then that looks pretty good. All right, VI vid9b.java. You guys know the drill. Public class vid9b with an open and a close. And inside of that, okay, so we're going to talk about operators. We're done with this. And don't bother to save any changes there. And all right, well, we'll just type into the notes first. Now, to be clear, operators. All right, we have 3 different kinds of operators. What we're talking about today are the arithmetic operators. Arithmetic. All right. And we're going to cover 2 more. So, gosh, this class here, very few people are using pencil and paper. Most are using keyboards. And of all of the pencils that are flying around, I think a lot of them are electronic, you know, styluses or whatever then. So not too big of a deal. But if by chance you're using a pen, leave yourself room for 2 more sets of operators that we'll cover in the future, and stick them back here in the same location then, if you will. So put a little placeholder here, and anyway here we'll maybe I'll put a question mark, be more appropriate. We'll fill these in later, but anyway. All right, so we'll start out with the most obvious ones. What the heck, we'll just go and type those in here. So how about addition, subtraction, all right, multiplication and division. And you know, also we could throw in, well, we'll hold off on those. We'll just do these 4. So let's write a little program. It's going to be short and sweet that flies through these first 4 pretty quickly, and we'll point out a couple of things, some of which will be a bit of a review from last time, but it doesn't hurt to cover things a second time. All right, let's use variables here, int I and j. All right. And we'll assign I a value of 7 and j a value of 2. So let's write a little program that will calculate the sum and the difference, and we'll kind of go from there. So, oh, what the heck? How about we int sum, and oh, what the heck? Just save a little bit of room. Oh, maybe not. Just in case we wanted to anyway, we'll use a separate line for the declaration and for the calculation. So let's make an assignment to sum. Sum is equal to I plus j, and we'll print out the result. All right, system.out.println sum is equal to, and then sum as such. As always, look at the data involved and calculate what the answer should be for you on the program. Then you can give the official nod, say, yep, that looks correct. So pretty easy in this case. I and j have the values of 7 and a 2. When I went to school, that summed to 9. So we'll expect that to happen. Let's go ahead and run this here real quick. Again, practice that incremental development. Oh yeah, I need to cat that. Cat vid9b.java. All right, Java C vid9b.java. Very good, Java vid9b. Looks pretty good. So let's jump back in. This is going to go pretty fast here at first, at least. So we're going to leave I and j the same, but let's go ahead and, all right, how about int? And we'll say difference. I'll be lazy and abbreviate that to just diff. And diff is equal to I subtract j as such. Oh, I'm going to be lazy and steal my print statement, but do remember to come down here and do a change word command and change sum to diff, a couple of different places. Oops. All right. There's that. I'll wait just a second here while you guys are plinking away. So, Adrian, did you lose the crutches yesterday then, or Monday? All right, very good. That's got to feel good. Okay. All right. Let's give that a whirl here. So we will cat and compile and run. Looks like a winner. And let's go ahead and do, oh, what the heck, we'll do multiplication or division at the same time, but then we're going to pause and scratch our head a little bit, kind of review something and go beyond it then that we talked about yesterday. Let's jump back in here and, all right, we'll go and just follow the same little pattern. Let's declare our variable int prod for product. And oh, what the heck, well, I'm going to really be lazy and just steal some lines. 3yy, p for paste, and change this to product. Change this to product, and change this to product with a dot. And then one other thing, it'd be easy to do, the old cut and paste error, copy and paste error. Don't forget to change the operator also to multiplication. Oh, what the heck, we'll run this real quick here. So we will cat and compile. And all right, 7 times 2 I think should be a 14. Looks pretty good. Back in we go for quotient then. We'll get some new twists, well, starting right after this then. But anyway, int QUOT, I'm going to limit myself to 4 variables here, I guess. 2 characters in my variable names. Change this to quotient. Same thing here, and same thing here, and change that operator to division. And I think I mentioned it before, but anyway, probably worth restating here. You know, we have listed our arithmetic operators over here to the side. Anyway, multiplication is the asterisk, which again, lazy computer programmers, we would generally call that a star because it's fewer syllables, easier to say. But no X, no back-to-back parentheses kind of a thing, or just an implication, 2i is equal to 2 times I. Nope, doesn't work. You have to be verbose there and throw in that arithmetic operator, which is only a star. All right, so on the quotient side of thing, again, this is kind of worth restating. Since I and j were declared to be ints, we talked about this before with constants in the last lesson, but now these are variables. But anyway, same thing applies. Since I and j were declared to be ints, well, you're going to calculate an int quotient. And again, it doesn't round, it truncates. It doesn't matter how close you are to that next limit, it's going to truncate down. And so in this case, 7 divided by 2 in the world of integers, that quotient is going to be 3. So we'll verify that, and then we'll talk about, well, what options do we have to kind of fix that, I guess. So let's see here. We'll cat and compile and run. All right, so the quotient is 3. And all right, so let's pull up our little drawing tablet here. Let's see, over here we go. And this. Okay. And oh boy, it's been, gosh, been a while since we've at least saved a picture. That goes back quite a ways here. But all right, so here's that and this. So 7 divided by 2. All right, so let's draw it out kind of long division like. All right, so 7 divided by 2. 2 goes into 7 3 times. You multiply the product of 6. You subtract. And all right, and let's kind of review some terminology here. So, all right, what is the 7 called? What is the 2 called? What is the 3 called? And oh yeah, also important here, what is the 1 called? All right, I think this one here is maybe an easier one to remember the name. So the 2 is the what in this case? Help me out. Divisor? Oh, very good. Okay, the divisor. It's, for me at least, okay, divisor, dividend. Oh yeah, the divisor is what you're dividing by, and the dividend is the other one. That's kind of how I think of that, seems like, All right, so dividend. All right, and oh yeah, the answer. Now we might say this answer is kind of incomplete, perhaps, shouldn't there be a 0.5 on the end of that darn thing? Remember, we're going to go and call that the quotient. Anyway, and what's this part down here called? The one? The remainder. Exactly, the remainder. So, yeah, I mean, 7 divided by 2, the quotient should be 3.5. But I'm going to say that it is just as accurate. There's no loss of precision or anything. If you say when you divide 2 into 7, you get a quotient of 3 with a remainder of 1. As long as you specify what the remainder is, that extra piece of information, then there's no loss of precision. Because, of course, what did you learn in 3rd grade or whatever when you first learned long division? That, oh yeah, you can take the remainder, and you can bring it up top here, and you can add the remainder divided by the divisor, right? Remember doing that? Anyway, so, yeah, you can, if you want, come up here and add the remainder divided by the divisor, and of course you can convert that into the 0.5, and 3.5 is certainly an accurate answer. But again, I'm going to say that 7 divided by 2 is 3 for the quotient with a remainder of 1 is also accurate. You're just given the data and the answer in a little different form, if you will. But how can we fix that if we wanted? Well, and let's just play around with it just for the heck of it, because I'm assuming this is new to most, if not all you guys. So let's jump back in here. And, well, we had a number of options that we did in the last lesson when we were dealing with constants. Remember, if it was a constant, you can put an F at the end of it, for instance, or a D for double, or an F for float, or something else like that. And, I have to admit, I don't think I've ever tried, but yeah, you can't do that here. This would work. Quote is equal to, we'll just throw it in just as a reminder, 7F, for instance, divided by 2. That's all it would take. A capital D would work also to specify that the 7 should be interpreted as a double, a 64-bit int. But the F says it's a 32-bit, excuse me, I said int, floating point number. The F says it's a 32-bit floating point number. And that's kind of enough to work here. We still have a little bit of a problem. We'll just verify that this will, well, I say that it will compile. I don't know for sure. Now that I look at this here, this is going to be, the quotient is going to be a floating point quotient now. And now we're trying to assign it to an integer variable. And we're probably going to get that loss of precision or the lossy conversion. We'll just verify that real quick. We'll cat for good luck. I think we don't have enough good luck here yet today to make that work. Yeah, possible lossy conversion. You've got a floating point quotient, and we're trying to assign it to an integer variable. And in fact, again, it's kind of irritating perhaps, but even if, what if I was to do the following? What about that? A 6 divided by 2. I don't care what kind of division you're doing, whether it's floating point division or integer division, 6 divided by 2 is 3. And there's nothing to the right of it other than perhaps a bunch of zeros. But I think even here, the bunch of zeros is going to be part of that answer. It's going to say the answer is a floating point quantity. And even though they're all zeros, again, we kind of see some limitations of the compiler. It's just smart enough every once in a while to be irritating, I guess, So we'll try that. Yeah, same thing. So The only way to fix that would be either, well, A, typecast it back down to an int, or we could do the following here just for the heck of it. We'll come here, and for this other little example, how about we do double dquote. All right, so a quotient that is declared to be a double, and there we go. So this now should compile. So yeah, even, you know, this again, you look at it, you recognize, well, ultimately that could be represented as an int, but it's not. If we're doing mixed mode arithmetic, a floating point quantity divided by an int quantity, it's going to calculate and return the result as a floating point. And anyway, so we need to assign that to a floating point variable. And we're going to, the floating point variables, we remember from our notes from back a few days, that double is our favorite of those, so we don't have to worry about doing typecasts and so on. So I think that should work, get us back to a point that will compile. All right, we will, oops, cat, and compile. Hey, very good. Just for grins, we'll run, but I don't think I've added any extra print statements, but just, if nothing else, keep it in our command history. Hey, there we go. So back in we go. So yeah, with a constant, you could put a D or an F after the end of one or the other of those things. But so my question to you, well, can I just put a D or an F after the I or the J? What would your guess be? And when you look at, you know, when I just asked the question, you might think, yeah, maybe so, perhaps so. But when you look at it, all of a sudden you realize, I'm not so sure about that. You know, IF, that looks an awful lot like a variable name now, doesn't it? You know, and of course Java's case sensitive, and you can do mixed, you know, you can mix up uppercase letters with lowercase letters and so on in your variable names if you want. You know, again, our identifier naming rules allow this, where we have a mixture of uppercase letters and lowercase letters and so on. So yeah, all of a sudden here it's going to think, hey, what the heck, I haven't seen that symbol, and that symbol that it can't find is the variable IF. So we'll verify that real quick. We'll cat for good luck and try to compile. Yeah, it can't find a symbol. The symbol it can't find is the variable IF. So that didn't work. But what's that other tool that we have at our disposal? Instead of specifying that I should be assumed to be a floating point number by putting an F or D after it, we showed you another trick previously. What's it called? You students, get out of my classroom right now. No, the typecast? Does that sound familiar? The typecast? Oh, there, that's right. Okay. So, yes. So we'll just either float or double, either one. Oh, I'll just use double, but it doesn't really matter. So this will work now. Now, because of this, we're telling the compiler, hey, treat I as if it were a double. So now we have mixed mode division, and it's going to calculate the result as a double. Then we'll still have that darn problem of we're trying to assign it to a integer variable, but it will put a D over here. Now D's not doing anything other than we're switching variable names. I have an integer variable called quote, and I have a floating point variable called dquote. And anyway, I think that should work. And oh yes, I need to change my print statement also. All right, dquote there, and dquote here. All right, as such. And we will cat and compile. Hey, very good. And run. Hey, there we get the right quotient. So anyway, and this will be, again, perhaps a lesson you'll need to apply on your lab 2. Of course, actually, I think that the division that you're going to be doing, the floating point division that you want to do on your lab 2 is not with variables, it will be with constants if you've looked up that formula for the volume of a sphere. But anyway, back in we go. Let's just pick back up with integers again. All right, so down to the bottom, and oops. So, all right, so we can do double. Yeah, quote. We'll do it this way: is equal to I divided by j, and print that out. So I'll steal that again as such, and that's going to give us the 3. And we're just kind of stuck with that, I guess. But oh yes, in the nick of time, again, referring back to our picture, and we did say in our picture that, well, the quotient is 3 with a remainder of 1. So the question is, how do we get our hands on that remainder? How do we get our hands on the remainder? Well, there's another operator. We'll go to our notes first, and we'll come back over here. The other operator, which we're going to conveniently type right after the slash for our division, and that other operator is the % sign. So that is an arithmetic operator called modulo or modulus, or sometimes just referred to as the remainder operator. I really like that they picked that as the operator. Of course, it kind of makes sense. We come over to our drawing tool, all right, and we realize, oh yes, this is the operator for division. And this is the operator for remainder or modulo or modulus. They look an awful lot alike. They both have that forward slash. It's just that the percent sign has a couple of little circles there, you know, above and below it. But they look very similar to each other. And boy, what you're going to see, in fact, oh, just for grins, I don't remember if I've ever done this or not. I'm going to highlight these two. All right, I'm just going to come here and highlight those and just show that those guys there are kind of best buddies. And a lot of times they work as a pair. As you can well imagine, integer division, you kind of lose some precision, but you pull that remainder, that modulo operator in, you can kind of get it back. And this thing will come in handy very often, and a few times in PF1, even more in PF2 and beyond. You can solve an awful lot of interesting little problems by doing integer division and then the remainder operators. So those often work as a pair. So let's throw that into the picture then. All right, so I'll tell you what the heck. I'm just going to come here and do a 3yy, P for paste. And now, oh, I need to declare this variable. I don't want to forget this. We'll call it rem. Change my operator. Come down here to rem. But I need to remember to declare that bugger or I'll get a compiler error. So how about int rem for our remainder? Okay. So I think that looks pretty good. So we know that, yeah, when you divide I by j, we divide 7 by 2. We saw earlier that the quote, as they calculate it as a double, the quotient when calculated as a double, is 3.5. But we're going to go ahead and do the same operation using integer division, and we're going to quotient of 3 and a remainder of 1. Let's see if that's going to work for us. We will cat and compile and run. Hey, there we go. Quotient of 3, a remainder of 1. So no loss of precision. The answer has just been expressed a little differently. Let's do one more here then. We'll do one more. All right. So how about down to the bottom we go. Int. We're just going to call this answer. Answer is equal to, all right, s divided by that, multiplied by that, ta-da, and then come up here, steal a print statement, and we're going to print out answer. All right. I mentioned this very thing earlier when we're looking at that pretty large expression there that the compiler actually will evaluate to determine whether it should compile or not. But so we mentioned it before, and again, it just same thing as what you learned in your math classes. But you know, I'd be tempted to have everybody evaluate that expression on their own and come up with an answer. And my guess is, especially, you know, you guys are all, you know, mathematicians, computer science, engineering majors, and so on. You've taken enough math classes. I think you should get this right. What really is kind of surprising, of course, you know, the truth is you can find any kind of crap you want to find on the internet these days, you know. But I have every once in a while just stumbled across videos with lots of views on YouTube on what is the correct answer for an expression such as this here. And there are people that will, you know, argue to their death, I think, that, oh, we're going to do multiplication first. All right? And so there's this big question is what is the real answer, you know, when you're evaluating this expression. And it seems kind of weird because at least in terms of all of the math classes I've ever had and the programming classes I've had and so on, there's no question here. There's no ambiguity. That, yeah, we all remember PEMDAS, and all right, multiplication and division are at the same level of operator precedence. And since these are tied, then you're going to evaluate from left to right. So, you know, if we were to do the multiplication first, then we'd get that product of 8, and then we'd take 8 divided by 8, and the answer would be 1. All right, so if you do multiplication first, this quotient here is going to be 1. But if you do the division first, 8 divided by 4 is 2, and 2 times 2 is 4. All right. So what's the answer going to be? Let's cat and compile and run. And I'm thinking we're going to do the left to right, so that's going to be 2 times 2, which is 4. But anyway, but of course, If in doubt, slap in some parentheses, just like you would in your math problems and so on. And you can put in an arbitrary number of parentheses, and it's all just fine. One thing I like about mathematics, and certainly applies here to computer programming also, you look at very simple little expressions like this, and it's no big deal. And pretty soon you are working on problems that involve expressions such as, where's the darn thing? You're looking at expressions that are more on the, on the scale of something like so. And it's kind of neat how, with mathematics, you learn these basic little rules, but they scale up to an unlimited degree, and ultimately same thing in programming. Now, the truth is, you could eventually get to some limits, perhaps on the size of an expression or something like that, but it's beyond anything that you'll ever come across unless you attempt to do so by have a program created. And that's, people will do that. I do that plenty of times for legitimate reasons. Have a program, write a program, which is kind of weird, not even really using AI, but just, again, because it suits my purposes sometimes. I need to write a program that does a bunch of stuff repeatedly or whatever, and so sometimes you actually write one program that generates another program as output. And so, yeah, you certainly could come up with a statement that is too long just based on buffer size and so on, limits built into the compiler. That's going to be kind of implementation dependent, but there's no real, I'll say practical limit on the size of expressions and so on. Let's see, we're doing just fine on time. It's a bit early, so we'll go and just push on instead of taking a break. I think we'll just go through the next lesson, if that sounds okay with you guys. Just one more example that's kind of weirder than what we've covered here so far. And then we'll wrap that up and switch over then, see if you guys have questions on Lab 2. So we'll start another little example then. All right, and we'll add in more arithmetic operators when we get to it. All right, how about vid9c.java? Public class vid9c. All right. So we're going to start off at least with just one variable. All right, it's going to really surprise you here. I think I'll use variable I. All right, knock you down with a feather there, right? Okay, so how about I will assign it an initial value of 5. And what we're going to do is we're going to, well, maybe we'll even print this value out just to be redundant here, I guess. And we're going to show you a number of different ways that we can increment variable I. To increment means to add something to, and by default, you normally mean to increment means by default, we're just adding 1 to I. So we'll show you several ways you can do that. I need to put a print statement for I. We're going to be printing it again and again and again. Let me go and just type 1 in here, I guess, and we'll copy and paste the heck out of it then. System.out.println. All right, I is equal to plus I as such. That should work just so. I know just to go ahead and get our command history set up and so on, so don't forget that. I'm going to go ahead and just compile and run this one here. One last look. You guys see any problems there? We will cat vid9c.java. Java C vid9c.java. All right. Java vid9c. There we go. Okay. So back in we go. So we're going to show you a number of different ways to increment a variable. Most common variable of all, of course, is good old variable I. How about I is equal to I plus 1? All right. Very, very, very extremely common line of code. Now, there's some shortcuts for this. That's what we're going to show you here this morning then. But anyway, incrementing variable I. And this is kind of the first version that you might learn on how to do this. This is an assignment statement. We're making an assignment to I. And what we're assigning to I is the value of this expression, which involves I. So we take the current value of I, we add 1 to it, calculate that sum, and then the sum is assigned across the equal sign to variable I, and I now has a new value, which is 1 greater than what it did before. We'll verify that real quick here with all right, copy and paste your print statement on down, and we will just verify that with a cat, a compile, and a run. Piece of cake. All right. So that is perfectly fine. There's a number of different ways that we can do that. All right. Another syntax, another way to increment a variable such as I would be to do something like this here. I plus equals 1. And a lot of times they scrunch it all up together there. You certainly could do that. You know, what the heck, we'll just do so, just to kind of be consistent with our spacing from before. But this is just a lazy man's technique of doing the exact same thing. We'll steal a print statement from up above real quick while we're at it. And so, again, I've mentioned before, programmers tend to be a lazy group in that, you know, they like to automate things. Something needs to be done. I'm going to figure out how to write a program to do it, and then I can prop my feet up and take a break or not come in to work or whatever it might be. You know, I'm going to automate routine, boring tasks, you know, things that are repetitive and so on. And anyway, well, this requires quite a few keystrokes. This requires a few fewer keystrokes. Therefore, it's an improvement. So it was tacked in after the fact just to recognize this is so common that how about we instead just kind of abbreviate it down a little bit. And I don't know about you guys, so this is an assignment statement. It is an assignment statement. Of course, we gave this an alternate form of an assignment statement. We gave you the syntax for an assignment statement previously. We just had you had a variable followed by the assignment operator. And here we've kind of messed that up a little bit. We know we have a variable and then a plus sign and then an equal sign. Shouldn't that assignment operator be to the left of the plus sign? And we could try that real quick. How about equals plus? Will it compile? The answer is yes. Will it run? Yes. Will it give us the result that we want? Maybe, maybe not. We'll try that here real quick just for the heck of it. We'll cat. So we're hoping it will increment I. We've got a plus thrown into the mix. It did compile. So let's see. I was 5 here. I was 6 here. I'm hoping it's going to be a 7 here. Whoa, that certainly didn't work out right. But we learned a little bit with this experiment. All right, this was an assignment statement. So I equals, this is kind of like we're used to having a variable, and then the assignment operator. That's what we have right here. And then this plus sign. Did we do any adding? Does it look like we did any adding here and we get a result of 1? We didn't. So what did this plus sign, what role did it end up serving? What did it do?
Just reassigned it.
We just reassigned I the value of 1. Did it ignore the plus sign? I mean, you could say it appears to have ignored it. Is there an alternate explanation for that? Oh, very good. There you go. Exactly right, Zach. Yeah, we just explicitly stated we want 1 to be a positive 1. Now that's the default, but we've learned something new. Oh, if you want, you can put a plus number, a plus sign in front of all of your constants, and it will just, you know, be unnecessary, perhaps confusing code there, I guess. But yeah, we're assigning variable I the value of positive 1. The spacing make it look kind of weird. You know, if we had done it like this, all right. If we had done that, oh, now, you know, kind of looks better. That looks like I is being assigned a positive 1. We recognize spacing has, the compiler ignores that totally. So it didn't matter that we had this instead. But yeah, that's not what we wanted. So we'll comment them out, I guess, just for the heck of it. And nope. This simply assigned I a value of positive 1. All right. So instead, how about I? All right. I plus equals 1. So we'll switch them back around the other way. And anyway, this is just the shortcut alternative syntax for I is equal to I plus 1. So let's try that. So again, this has been commented out. So we had I is equal to 5, I is equal to 6. We're hoping this time for a value of I is equal to 7. And so we'll cat and compile. And hey, there you go. Worked just fine. And you know, to be clear, I won't bother to demonstrate. Oh, what the heck? We'll just do this real quick. We will. 2yy, p for paste. And you know, yeah, you could also do something like so. I plus equals 2. That's just a shorter notation for I is equal to I plus 2. So here we printed out I is equal to 7. And now we're going to add 2 more to it. So I think we'll get to a 9, for instance. We'll verify that real quick. All right, cat and compile and run. There you go. All right. So now let's switch gears and show you yet another even shorter syntax to do the same thing. Okay, so back in we go, down to the bottom. All right. So, oh, just for the heck of it, we'll kind of reset back where we were. In fact, I'm going to do the following. System.out dot print line, just an empty print line statement to have a blank line in the output. And we're just going to kind of reset us back to where we started out with I is equal to 5. And I'm going to steal a print statement that prints I, like we've done before. And I'm going to, oh, tell you what, that's right, we'll do the same thing. We'll print out I as 5, and then we're going to get ready to increment it using yet another syntax. We'll just verify that that gets us back to 5 real quick. We'll cat and compile and run. All right, so I is back to 5, kind of starting out again. And back in we go, capital G to zap to the bottom. And I'm going to print I again after I show you another way to increment variable I, which is I plus plus. So that's a kind of a weird looking assignment statement. So this is again an alternate syntax, which is just, again, lazy programmers. This goes back to Ken Thompson and Dennis Ritchie, you know, working on the early C programming language in the early 70s, all those years ago. And again, they're just saving themselves some keystrokes. So I plus plus ultimately is identical to I plus equals 1, which is identical to I is equal to I plus 1. It's just a shorter syntax. And, you know, it certainly doesn't look like an assignment statement because there's no assignment operator. There's no assignment operator there at all. But, again, just recognizing that something like this is so very common, they wanted the shortest possible syntax. Hey, just express the variable name. It doesn't have to be I. Any variable, you slap a plus plus at the end of it, and you have incremented that variable. And again, the default is 1. Now, with this plus equal notation, you can specify what you want it to increment that variable with. Do you want to add 1 to it? Do you want to add 2 to it? In fact, it could be a variable. I plus equals j. And it would increment I by adding j to it and so on. So this is more flexible. You know, of course, this here is very flexible, as is this. This is less flexible. All you can do is add 1 to your variable. But since adding 1 is something that happens oh so often when you're counting and different things like that, they've given you just a syntax just for that. So we'll verify, well, with a quick cat, let's see here. So cat and compile. All right, so we kind of have been reset here. So here, this is a 5. Here I should be a 6. Let's verify that it is a 6. So when you runner, it's a 6. Looks pretty good. Jump back in. We're going to show you an alternate. In fact, I'm just going to do a 3YY and a P for paste. But I'm going to change this. Instead of I plus plus, it's going to be plus plus I. And this is where it gets a little confusing. You know, this is going to work, and it's going to work like you might guess. It's going to appear to work identically to the way that the previous incrementing of I did. But when we dig a little deeper, we'll uncover a subtle difference between I plus plus and plus plus I. So let's run her here and verify that, at least to the casual observer, those things appear to be equivalent. All right, so let's see. We'll cat and compile. Let's count here again. This printed out a 5 and then a 6. I do believe this should be a 7. We'll verify that it is. So at least at this level, it appears that I plus plus and plus plus I are the same. All right, but let's dig a little deeper. Let's dig a little deeper. Okay, so back in we go. And I think, oh, just for the heck of it again, I'm going to kind of reset things here with an empty print statement. And I'm going to also introduce another variable, int j. Okay. And what the heck, let's go ahead and reset I again back to 5. I is equal to 5. So I has once again been zapped back to our official starting point of 5. And we have a new variable into the mix. And then I'm going to do the following. All right. And for the new programmer, this is probably not something you would want to do, but it will work. So we'll check this out. Oh, that's right. I need to, oh no, I don't need to in this case. We're going to just say j gets assigned I plus plus. I'll tell you what, let's start with plus plus I. We'll do that. And then I'm going to come up here and I'm going to print out I, and then I'm going to print j. I'm going to let y'all catch up with me here then. So this is new here since the last program, that time we ran this program. Introduce variable j, reset I back to 5. Oh, we threw in an extra print statement also just to put a break in the output there. And now I'm making an assignment to J. And what I'm assigning to it is the result of this expression over here. So it's kind of weird. We call it I plus plus or plus plus I. Those are assignment statements, but they also return values. And to be clear, I'll just type this in maybe here on the old command line as a comment. If I have all of these variables declared, and if I say I is equal to J is equal to K is equal to L is equal to 5, my question is, assuming that I, J, K, and L have all been declared, then my question is, would that compile and run? It would. So what the heck? How's it going to be evaluated? You know, we're assigning I what's in J. Well, what's in J? J's getting updated based on what's in K, and K's getting updated what's based on L. So in this case here, we need to evaluate this sequence of assignment statements from right to left. So L gets assigned a value of 5, and here's the thing. An assignment statement, normally we're not concerned about this little piece of trivia, but an assignment statement like L equals 5 returns a value. That assignment statement, L equals 5, returns a value. What value? The value that was assigned to our variable here, it returns 5. So this assignment statement, yeah, we're assigning L a value of 5, but also the assignment statement itself returns a value of 5, which is assigned to K. And then this assignment statement returns a value of 5, which gets assigned to J, and so on. So yes, this would compile and run, and it would assign all 4 of those variables the value of 5. And so with that in mind, when we do this here, this is an assignment statement, and it returns a value. Okay, so I is a 5. We're incrementing I to 6. And it's going to print out, hey, I'll tell you what we'll do here. We'll do YY. I think I might have done a cut and paste instead of a copy and paste. We'll put a print statement there. We assign I a value of 5. It's going to print, and it's going to be a 5. We're going to execute this plus plus I, and we're going to print, and I is going to be a 6. But the question for you, what value is going to be assigned to J? Is it the 5 or the 6? Is it the pre-increment value or the post-increment value? We'll just test it through trial and error here and see which one. Is it going to be the pre-increment or the post-increment value? Let's cat here and compile. All right, and run. There we go. All right. So looking up here in our code, I was 5, and it printed out here. We incremented I. We've got this embedded I, or plus plus I here, and it did its magic, and it incremented I, and sure enough, when we printed I again, I now has a value of 6. But this assignment statement, it is assignment statement, even though there's no assignment operator there, it's just this ultimate shorthand version. This operator did return a value. And we see what value it returned because we took the return value and assigned it to J, and we printed out, okay, and it gave us a 6. On the other hand, back in we go, down to the bottom. Let's steal these, all right, we might steal these 4 lines plus another one, I guess. Let's do a 4 YY and a P for paste, and I'm going to change this now to I plus plus. And oh, once again, how about we do the following. I'm going to take these 2 lines, 2 YY and P for paste. All right. So we're going to assign I back to 5 again. And then we're going to do the same thing that we did before. We're incrementing I, but we're taking the return value from this assignment statement. We could call it an expression here, but it also makes an assignment to variable I. It's taking the return value from this assignment statement and assigning it to J. Now up here, when we did this, I was 5. We printed it as a 5. And then after the assignment took place, J was a 6. Let's see if we're a 6 down here. So is the last line of output we get, is J going to be a 6 here also? All right, we'll cat and compile. And the confusing answer is no. We assigned I a value of 5. we executed this statement here, and when we finished, j was 5. So there's a subtle difference between plus plus I and I plus plus. Now up here, here, and here, it didn't really matter. But if you put yourself in a situation where, oh, the result of this assignment is being used for some other purpose, such as assigning a variable, then there's a subtle difference. And it's pretty easy to explain where you'll understand. Let's go to our drawing tablet here. All right. So here's how to explain that and make it all clear. So let's talk about, all right, you know, I plus plus versus plus plus I. So what I want you to do, which comes natural to us here in the West, we read from left to right. So we're going to read that expression from left to right. And note we come across the variable and then the operator. Down here, on the other hand, when we're reading from left to right, well, this here is the operator followed by the variable. Okay. So both of these will increment I. It's as simple as that. Both of these will increment I. But the question is, what value gets returned? Notice here, the variable comes first. So we set aside the value of the variable, and the current value of the variable is what gets returned. And then the variable is updated. But what gets returned is the pre-update version. Over here, the incrementing comes first, so we increment before we get to the variable. So when we get to the variable, then we set aside its value at that point in time after it has been incremented. So we increment and then get the return value. Here we set aside the return value and then we increment. So does that make sense then? So when we look at the code, all right, back to here we go. So I had a value of 5. We increment I, and then once we get to the variable I here in this expression, then we that is what gets returned. So I was 5. We increment to 6, and then the 6 is set aside as the return value, and then assigned across the equal sign to variable j. And so this printed j as a 6. On the other hand here, all right, the current value of I is set aside, reading from left to right again, the current value of I is set aside for the return value, and then I after the fact is incremented, and so I did become a 6, but j was still a 5 here. So I'm going to say these are perfectly fine. I mean, they worked, and now that we understand how and why they work, there's nothing wrong with these assignment statements. But let's go back in and add a couple of comments. All right. So first off, all right, I plus plus. This is our number one fave, way to use the plus plus operator. All right. This here is also good, but maybe not our fave. All right. And these other things, they're kind of more advanced, and they're okay under some circumstances. Circumstances. All right. There we go. I'll get that right. And then down here, same thing. Oops, that did work. Okay, got to type the whole darn thing again. All right. So let's bring up one more little example here. Then we're going to wrap this up here pretty quick. Let's do a system.out.println. For a blank line of output, once again, we'll set I back to 5. And every once in a while, we'll print it out then also, just for grins, we'll print I. And okay. Every once in a while, we'll see something like this. Okay. So we'll ask you guys to bench execute. Don't remember if I've mentioned that term before. I probably have by this point. Bench execute means to just look at the code, sit down at the desk with pencil and paper and kind of figure out what it does so you are the computer, if you will. So we're going to bench execute these 4 lines of code. I get assigned a value of 5, and we print it out. I is 5. Then we execute this, and we print out I. Well, the good news is I ends up being 6. I ends up being 6. Does that mean this is okay? Well, it worked, so I guess it's okay in that regard. But let's again, now that we've kind of studied up here with variable j thrown into the mix, now we're just using only variable I at 2 different places in this. We kind of have 2 assignments going on. Right here's one, and here's another one. So let's review what happens, what this here means. This means we're going to increment I, and then we're going to set aside the incremented value, which will be assigned to I. So when this expression is evaluated, I is 5. We increment it to 6. And then we set aside the 6, and the 6 is assigned to I. So this, it's going to work, and it's going to give us the 6. So it's kind of a subtle little problem, if you will. Compile. Oops. Ah. So much for my golden code today. Somebody probably saw that. Let's see. Where was the darn thing? I equals plus. No, let's see here. Let me scroll up. I thought it was on that last statement I typed. Semicolon expected. Oh, j equals I plus. I must have deleted something earlier on. Good heavens. Okay, line 45. Colon 45. And all right. Somehow I zapped the semicolon when I was editing earlier. Okay, so let's try again. Cat and compile. Okay. And I believe it's going to print out as a 6. So what's the problem? Well, the problem is this isn't necessary. Making that assignment to I is not necessary. The plus plus I is going to increment I and update I. So we update I, then we set I aside and assign I to I. All right, so that is kind of equivalent, if you will. All right, so we'll just kind of as a comment. This is kind of logically equivalent to okay, so hey, this increments I, and then we're making an unnecessary assignment from I to I. So now chances are, if we were to code up something like this, the compilers, I mean, every once in a while I talk about computers being dumb and the compilers having their limits and so on, but they will look for obvious little things, little inefficiencies in your code, and they will optimize your code. By default, you have to tell them not to do this. In fact, don't optimize my code. I want you to convert it to assembly code and machine code just as written. Trust me, I know what I'm doing. Don't work your magic, which by default is to optimize your code a little bit. And so it could be the case that when the compiler sees this here, it ultimately kind of just turns it into a plus plus I and leaves this part off. We'd have to have it generate the assembly code and go in and look at it. I need to do that sometime, that very thing, in fact. So it might kind of end up being okay at the end of the day, but this here is a wasted assignment here that's not necessary. So let's put a comment here that says don't do this, and then we're going to study one more little example. All right, don't do that. And then even worse. Okay, so one last thing here, and once again we're going to kind of follow the same little pattern. We're going to print a blank line. We're going to assign I a value of 5 and print it out. And then, all right, then what we're going to do is the following. How about I is equal to I plus plus? It's kind of the opposite of what we did before. This was not good, but it worked, but it might run a tiny bit inefficiently because it has an extra assignment that's not really necessary. And if nothing else, it just kind of shows maybe that you don't know what the heck you're doing. But, new students will sometimes do this. The reason I introduced this early on is because, hey, we're wanting to make an assignment to I. And students, dadgummit, they want to put an I equal into the mix. And we have this other operator that the old guy talked about, so they're just kind of combining things that are a little bit confusing. Sometimes students will come up with this. So I wanted to just cover it and say, nah, don't do that. If you're wanting to use that plus plus operator, just use it like this, okay, or this, all right? Or actually, I should go up even further. Just use it like this or like this. There we go. But this one here is the worst one of all. So once again, let's bench execute this code. I has the value of 5. It gets printed out. Now, my question for you is, what is the return value from that expression, I plus plus? It does increment I. Yes, it increments I. But what value does it return that gets assigned to I? 5. Okay. So again, it has that touch of inefficiency, kind of like up here it increments, and it also has an assignment to I. It has that same touch of inefficiency. But here, all right, I is 5. So when we're looking at this expression, all right, I plus plus, I does get incremented, but again, reading it from left to right, the current value of I is set aside. That's the return value. So I is 5. We set aside the 5 to be returned. I's bumped up to 6. It becomes 6 for one instant in time, and then we return the 5, and I gets knocked back down to 5. So it's a waste of time, and we kind of stepped on our own toes or whatever there. We clobbered the update that was part of this assignment statement, and even though I was 5 and we did execute an I plus plus operation here, when we print it out, I will appear to be, I is unchanged. For a brief instant, it became a 6, but it got demoted back to a 5 again very, very quickly. All right, so kind of weird. And, you know, was this interesting perhaps? I don't know. I like to cover things like this that hopefully will make things a little more clear when you accidentally stumble into something like this. Because otherwise, if you did this and we hadn't covered this lesson, you would, send me an email, the system isn't working right, and I made an assignment to I and it didn't work or whatever, So sometimes you have to just study things at a little deeper level to make mysteries clear then at that point. So let's go back into our code and add one more comment. We're going to wrap it up then. Gosh, this could be a nice easy day. So in other words, this one here is the worst of all. No, do not do this. All right. So this one here, was just a little less efficient, but it kind of sort of worked like you would expect. But this did nothing other than waste our time a little bit, and I remained unchanged, as far as you can tell, at least the end result of it. Questions on that? All right, my friends. Hey, I can't believe it. We're actually going to have a lab period, so if you guys have questions on your lab then stick around and ask those. We'll stop the video here pretty quick, and we'll remind you guys of the due date then once I stop the video. And for y'all that might be watching this video at a point in the future, just check Blackboard for the due date then for Lab 2. So let me go ahead and wrap this up and stop this, and then we'll mention that due date, and then we'll call her quits for today then. All right.